In this video, we want to answer this question that says, explain why the electronic configuration of chromium is argon 3d5 4x1 rather than the expected argon 3d4 4x1. Now, the answer to this is because of the stability of the d orbital. When filling the orbitals with electrons, we have the s, p, d, and f. 1s, 2s, 3s, 4s, 5s, and so on. One step down, 2p, 3p, 4p, 5p. One step down, 3d, 4d, 5d. One step down, 4f, 5f. When filling the orbitals, the electrons into the orbitals, you begin with the lowest energy level, which is the x. Filling, if electrons are remaining, put the 2x. If electrons are remaining, put the 2p. If is remaining, put in 3x. If is remaining, put in 3p. If is remaining, put in 4x. If is remaining, put in 3d. If is remaining, put in 4d. That's how you fill it. If it's remaining, put here. If it's remaining, you put here. If it's remaining, you put here. So now the chromium is 24 electrons. So chromium want to fill in 24 electrons into the orbitals. Now we put 1s. S contains maximum of 2 electrons. P contains maximum of 6 electrons. D contains maximum of 10 electrons. F contains maximum of 14 electrons. So for X, we give him 2. The next one, 2X, we give him 2. After 2, the next one is 2P, 6. The next one, 3S, we give him 2. After the 3S, we go to 3P. 3p, we give him 6. Now if you check, this is 18. This person is actually argon, 18 electrons. So this is actually argon, so we represent this with argon. So the next thing now we need to fill is the remaining 6 electron to make it 24. Now after the 3p, we're supposed to fill the 4x. Let's just say 4s. Let's write it very fancy. 4s. So you can see it. 4s. We're supposed to give it 2. If you give it 2, the 3d will now be the next, which is now the one that is now supposed to take the 2 electrons. But the d orbital does not take anything like this. So what will be done is argon, which is this, the 3d is 4, not 2, 4 to make it remaining 6, 4. So it will not take this 4. What it will do is it will take 1 from this x and put here to make it 5. So because the d orbital can either be partially or completely filled, so he will take 1 from this person. So what you will now have is 3d5. This one now will have the remaining 1, 4s1. So that is why chromium is this way. The reason is because of the stability of 3d orbital. The 3d or the d total, the d orbital is either partially or completely filled. So what you can have is d, you can have d3, you can have d5, or you can have d10. So this is how the d orbital exists. So this is why chromium doesn't stay this way. 3, 4, d4, no, it doesn't stay this way, rather it stays this way.